Good morning. In other examples, we shall be looking at if sine x minus alpha is equals to x plus alpha, prove that tan x is equal to 1. So you'll observe that those are compound angles, and we are still emphasizing the principles or the concept of compound angles. So we are going to simply expand the sine x minus alpha and also expand cos x plus alpha. Then after, put the sine x together and the cos x together. Then later we shall obtain the tan of x and it will simply come out itself. So we first expand that. Once you expand sine x minus alpha, hope you are conversant with that by now. It is the same as sine x cos alpha minus sine alpha cos x. And once you expand cos x plus alpha, you obtain cos x cos alpha minus sine x sine alpha. So we now collect like terms where there is sine x. Why? Because we want to find tan of x, and tan of x is the same as sine of x over cos x. So you'll observe that I've taken over sine x plus sine x sine alpha to the other side, and I've also taken over sine alpha cos x to the right hand side. And so as I now divide through by cos x on both sides, you obtain sine x over cos x. And once I divide through by cos alpha plus sine alpha, you'll obtain cos alpha plus sine alpha over cos alpha plus sine alpha. That is simple algebra. Please don't get lost. Put it on a paper and see how it comes out. I'll always advise that you do it such that you see where it comes from. So once you cancel that, you'll obtain tan x is equal to 1. So we are going to also prove if A, B, C are angles of a triangle, prove that tan A plus tan B plus tan C is equals to tan A tan B tan C. What is a simple fact about angles of a triangle? We know that angles of a triangle, the interior angles, ought to add up to 180, meaning A plus B plus C is equal to 180. Once you introduce tan on this left hand side, you are supposed to introduce it on the right hand side also, and you will now obtain that particular expression. And so you'll observe that tan A plus B plus C is a compound angle, but this time around it is having 3 of them, but we are used to 2. What do? We substitute for 2 angles there with 1. So we shall let A plus B equal D. And if you rewrite that, you'll observe that we have obtained a compound angle of tan of only 2 angles which we are familiar to. So once we expand tan D plus C, you obtain tan D plus tan C over 1 minus tan D tan C. However, we know that tan D is the same as tan A plus B. So we also expand tan A plus B and you obtain that expression. And so what happens now? We are now going to replace for wherever there is tan D, we put tan A plus tan B over 1 minus tan A tan B in the expression above. This is still algebra trying to confuse us. However, the trigonometry has just stopped down there and now we are doing algebra. So once we substitute that in our equation there, we shall obtain that particular expression. Hope you are trying it out on your paper. However, we know that the whole of that is equal to tan 180, and tan 180 on our calculator or in the very first principles that we looked at is equal to 0. So once you cross multiply, you observe that the denominator will simply disappear because any number multiplied by 0 is 0. So we remain with that smaller expression of the numerator. And once we also expand or get the LCM down there, the denominator would have disappeared, and the numerator would remain as tan A plus tan B plus tan C equaling tan A tan B tan C. Thank you.